Good morning, Calc BC. Um, it is Friday, May 8th, and going to give to you guys my take on the day one 5 for 5 worksheet from the Dropbox. We talked about this worksheet a little bit yesterday in class on Thursday, but I haven't really looked at the solutions. I'm going to go through this in a 15-minute time frame, see what happens. But what I do know I'm doing every time is trying to create the real life scenario of the test. So um, I'm going to have this printed out just to be able to show the problems and talk about it with you. But if I were you, I wouldn't be printing it out. I'd be using the screen. In addition, I also have my 5 pages ready to go with my ID number, my initials, and the page number. All right. And maybe a couple extra blank pages in case you want to toss a page and start over. All right, I've got my timer. My screen is the display mode is set to never auto lock, so it's going to stay on. So the timer is going to be in my face. That helps practice the real life scenario because the screen will have the timer on it. And so let's go ahead and see what we can do. I'm going to set the timer and then imagine I had never seen the problems before and see how many problems there are. And then from there, I'm going to parcel out my worksheets accordingly before getting to any math work. Here we go. All right, so the test was given to me. I see I have a BC 1, 2, 3, 4, 5. So that means I'm going to be able to do BC 1, BC 2, BC 3, BC 4, and BC 5. And I know that sounds silly to do, but it's a good way to just be more organized and have it labeled because you got to have it labeled at some point. Here we go. BC1. We are looking at a function, continuous, 3-line segments, semicircle, G, integral, variable limit. Let h of x equal f of that. Find the derivative at 3. Got it. Okay, so I need h prime of x. Derivative of the outside times derivative of the inside. Done. BC2. Evaluate. DNS, good stuff. Maybe you messed up here and called this 0. It's looking for a second degree Taylor polynomial about x equal 2. Well, I want to just set up that structure first. And I know G prime from earlier, I think. No. Oh, okay, I need G prime too. I'm just going to write that. Okay, so I need G prime too. Okay, I need this first. I'll do that. So that's the area under the curve from -2 to 4. That's going to be the area of the semicircle, pi r squared, half of that, plus 1/2 base times height. Got it? Okay, I need G prime of x. G prime of x is equal to the derivative with respect to x of the integral from -2 to x squared of f of t dt. Okay, so fundamental theorem, capital F of t evaluated from -2 to x squared. Okay, that's derivative of that is 0. Derivative of this is derivative of the outside times derivative of the inside. So therefore, G prime of 2 is equal to f of 4 times 4. F of 4 is 0. Interesting. Okay, so this thing just goes away. G double prime is product rule. First times derivative of the second plus the second times derivative of the first, which is derivative of the outside, times derivative of the inside. So G double prime of 2 is f of 4 times 2 plus 4 times f prime of 4 times 4. Well, f of 4 was 0. And so this equals 16 times f prime, which is the slope, which is -2. Okay. So now I have p sub 2 of x. I've already started it here, and it got nice. It was plus 0, and then plus -32 over 2 times x minus 2 squared. I think I got it. It's the best I got. I only got 6 minutes. I got 2 more problems to do. There we go. BC4. P sub prime of 5 is approximately something. Oh, okay. Well, that's the slope, and I have the original. I don't know the point with saying approximated, so that's I just needed some sort of slope, change in y and change in x. So change in y over change in x which is going to equal 10 minus 5 over 6 minus 4. I don't think I need units because it says approximate p, like give the value, and then it says using units interpret the meaning. So p sub prime of 5 represents the rate, because it's a derivative. So it's the rate of what? It's the rate of this thing, which is already a rate. So it's the rate of the rate of people entering the school measured in people per second per second. All right, BC5. Using a left Riemann sum, 3 subintervals, approximate. Okay, so 1/6 integral from 0 to 6, I think. Yeah, of p of t dt. Okay, got it. Is approximately equal to 1/6 times the Riemann sum. It's a left Riemann sum, I think. Yep. So I'm going to do base times height times base times height times base times height. I'm going to take the left side of the interval. First one, base is 1. Height left side is 8. Plus base 3, height left side 3. Plus base 2, height left side 5. Got it. Done. And the meaning. Okay. So 1/6 times the integral from 0 to 6 p of t dt represents, I think that's how I said it in the previous one. Yeah, I like that. Represents the average. Well, it's the average value. Okay, so it's the average value of something, and the value of something is p, and that thing is the rate. So it represents the average rate at which people enter a school over the time period t equals 0 to t equals 6 seconds. And actually, 2 minutes and 40 seconds to spare, and I only had 6 minutes left to do the last two problems. And so I want this to be maybe a testament to how just stay calm. Like, I didn't really look at the timer too much. You know, I looked at it after my third problem. I really didn't look at it after the first three. I was going as fast as I could. And they're supposed to be giving you enough time to do this. I know it doesn't seem like it, but if you're doing the problem and you're thinking it through and you have an action plan and you're writing the question down, paraphrasing it, I think we can do okay here. Let me just run through it. I have 2 minutes. I'm not going to waste my time. I'm going to, if I have extra time before the 5-minute bell, which we should stop at the 5-minute bell and get our things turned in, it's just to make sure we answered all the questions. Okay, the first one was a derivative. The original function, did I write it down right? You know, did I get my pluses and minuses correct? It's those little things. Did I simplify? If so, can I double check my simplifications? Because at times it is better to simplify. I get it. Well, and see, you got to lock the animals. I just had, my cat's doing something in the window now, and it's bothering me. And this is precious time. So doing these run-throughs now and figuring out where you can lock your animals and or little brothers and sisters can make a big difference on how we perform on this exam on Tuesday. So derivative, did I write it down right? Yes. Okay, next problem. Integral, did I get the bounds right? Yes. Did I write down the problem correctly? Yes. And The cat is killing me. Get out of here. 55 seconds. Okay, I gotta move on. I think I did BC2 right. BC3, did I write down the correct stuff? Wow, that was a tough one. I'm not sure. Let's see. Yeah, it's about 2, so it's x minus 2 and x minus 2. Divide by 0 factorial, divide by 1 factorial, divide by 2 factorial. It's a second degree. Yes, second degree. It's those little things. And then set it up and look at what you need. So when I wrote down what I needed, I plugged in. I realized that what I was about to do here was too much work to do in that little space. I needed a whole, separate section. It turned out to be 0. This ended up having some geometric idea because I was given a graph. I don't need the equation. I can geometrically find the area under that curve. Just DNS that, and then here, okay, I'm done. And I would take pictures and I would turn it in. And you don't have to worry about your ID or the page number or any of that stuff, right? And this is now my third time doing one of these. And I feel like I'm getting better at it each time. I'm getting calmer during the timer. I'm getting better at just paraphrasing the question onto my paper in a very succinct manner. And I bet if you rewatch my first one, I'm in like panic mode, kind of. So hopefully you can use this video. You can pause it. You can look at it. You can please comment if there's a notational error or something actually wrong with this, because I'm not looking at the answer key. All right, folks. Until the next one, BC 5 for 5 day 2 should be out soon. Thanks. Bye.